This is a weekly summary of interesting news that is relevant for my lectures at the Eastern Switzerland University of Applied Sciences. My name is Thomas Bocek, and today we will discuss 6 topics. The first article is the following here. Here it's a CTO at a customer support software company published this article about how AI coding tools changed their work in recent months. The author claims productivity increased by 2 to 3 times compared to before. The interesting part is not how much the CTO codes, but the key shift is in what the work involves. Previously, CTOs who wanted to code had to write every lines themselves. Now, AI tools handle code generation while the human provides context and makes decision. For example, the author can tell an AI tool to build a data export matching existing formats with additional fields, and the tool generates most of the code correctly. And this works because the author knows the code base architecture and requirements, while an unfamiliar engineer would spend much more time on the same task. And the author argues AI tools have not replaced technical judgment or system knowledge. Instead, these skills became more valuable because they let you direct AI tools effectively. The role transformed from manual coding to providing specifications, evaluating AI-generated solutions, and making technical decisions. The author emphasizes that deep context about the system is what makes this productivity gain possible. The next article, this one is in German. Here the Swiss Army had 7 IT projects in critical status by mid-2024. And the Parliament's finance delegation warned of potential billions Swiss franc in damages. By late 2025, 5 of these 7 projects returned to an acceptable status. And the Army's new Cyber Command made a major change in project management methods. They stopped using traditional 5-year project cycles with multiple hierarchy levels and switched to scaled agile framework, which we also teach here at OST. This is an agile project management approach that has been used in IT companies for about 25 years. Finally, it arrived at the Swiss Army. Under the new method, development teams work in sprints of 2 weeks each. After 5 sprints, all participants meet in a big room planning session. They review what was achieved, assess the current status, and decide next steps. Then another 5 sprints follow. The program leader states they now work step by step with close involvement of end users instead of having suppliers work for 5 years and potentially deliver something that does not fit requirements. The focus shifted to iterative cycles with regular validation rather than long-term parallel projects. The next article is the following here. It's about AWS, and this is about the Monitor platform company. They published a follow-up report 2 years after moving their infrastructure from AWS cloud to bare metal services in data centers. The company now reports annual savings of $1.2 million compared to their previous AWS cost, which is 67% less than they would have paid on AWS. The company runs their systems on physical servers they own, located in co-location facilities in Paris and Frankfurt. They use open source software, including Kubernetes for container management and Ceph for distributed storage. The infrastructure has maintained a 99.993% availability over 730 days of operation. The company states their uptime was better than AWS, noting they avoided region-wide AWS outages that I covered the last time. And the migration required approximately 1 week of engineering time. ongoing maintenance takes about 14 engineer hours per month, which includes kernel updates, storage system checks, and Kubernetes upgrades. The company states this is similar to the time they previously spent on AWS cost optimization and configuration management. The company addressed concerns about hardware failure risks by deploying servers across 2 different data centers with different power providers. They still use AWS for specific services like long-term backup storage and content delivery networks, where cloud economics remain favorable. The article notes that cloud service remain the better choice for workloads with variable usage patterns, heavy reliance on managed database services, or when teams lack infrastructure expertise. The company stayed on AWS for their first 5 years before migration made economically sense. Now, the next article, it's the following here. It's a BBC report, and this happened on Wednesday. Microsoft Azure experienced a global outage that took down multiple services for several hours. Azure is Microsoft's cloud computing platform and holds approximately 20% of the global cloud market. And the outage affected many websites. Microsoft stated the cause was a wrong configuration change that led to DNS issues. The company restored services by rolling back to a previous update. And this outage occurred 1 week after a similar AWS outage caused also by a DNS problem. These recent incidents highlight how concentrated cloud infrastructure has become. Just imagine Microsoft, Amazon, and Google have a big outage. That means this can disable hundreds or thousands of applications simultaneously. The next article is about the European Commission. It's this report here. The European Commission published a report in October 2025 on submarine cable security, which is a topic I also talk in my distributed systems lecture. The report addresses critical infrastructure that carries approximately 79 to 89% of global internet traffic. The report identifies several infrastructure vulnerabilities. Europe has over 300 submarine cable landing stations, but still depend on a few critical points. The Red Sea remains a bottleneck where 90% of traffic between Europe and Asia passes through. Some island member states like Cyprus, Ireland, and Malta rely almost exclusively on submarine cables for internet connectivity. The report examines market concentration risks. US hyperscalers already own 90% of total capacity on cable connecting the US and Europe, and are increasing their share on Europe to Africa and Europe to Asia routes. Traditional European telecom operators have decreased their investment in cross-continental submarine cables. The report identifies supply chain dependencies. Europe has one major cable supplier, Alcatel Submarine Network in France, but depends on non-EU entities for critical components. Optical fibers for long-haul cable comes exclusively from US and Japanese companies. Optical amplifiers and repeaters are manufactured only by US companies. Microchips for transponder are largely controlled by Taiwan and South Korea. Regarding maintenance capability, the report notes that cable repair capacity face pressure from an aging maintenance fleet and increased total cable length installed by hyperscalers. Some repair vessels have been repurposed for installation to meet deployment demand, which absorbs repair resources. And the report developed 7 risk scenarios ranging from coordinated physical attacks on cables to supply chain disruption and natural events. These scenarios include escalation stages for stress testing infrastructure resilience. The next article is the following here. It's about client-side rendering, and I talked about improving static side rendering, client-side rendering in the application architecture lecture. And I also mentioned React server components, and here is an article, developer reports on 1 year using React server components in Next.js and the migration away from React server components. So React server components split code into server and client parts. Server components run only on the backend and can access database directly. Client components handle user interactions. The problem in client components can also run on the backend, making the naming a bit confusing. And the team found several issues. First, optimistic updates became nearly impossible because of server components cannot change after loading, and this forced splitting code into multiple files awkwardly. Second, every page navigation required fetching from the server, even when the browser already had the needed data, and this made navigation slower than necessary. And third, layout had artificial restrictions that made data sharing between components harder. Fourth, the system sends page content twice, once as HTML and once as a special format for React, doubling the bandwidth. And the team migrated incrementally to 10 stack start by creating stub implementations of Next.js APIs. They redirected Next.js imports to their own implementation using Vite configuration and after migration. Their site was faster in development and had better page load times, quicker navigation, and costs less than their deployment with Vercel. And in the lecture, I showed many improvements to client-side rendering, and this article is also about these trade-offs. The next article is about Kafka. It's the following here. Developer benchmark PostgreSQL as a messaging system to challenge the assumption that specialized tools like Kafka are always necessary. The tech industry often adopts complex distributed systems when a simpler solution would work. Two trends support this view. Small data movement, recognizing most workloads are smaller than assumed, and the PostgreSQL renaissance showing one database can handle many use cases. The author tested PostgreSQL in two scenarios. First, as a publish-subscribe system where multiple readers consume the same message. They created tables that worked like Kafka's log structure with monotonically increasing offset. Writers insert batches of messages while readers poll for new data in consumer groups. A small 4-CPU PostgreSQL instance handled 5 megabytes per second writes and 25 megabytes per second reads. A 3-node replicated setup maintained similar throughput with acceptable latency increase. A large 96 CPU instance reached 240 megabytes per second writes and over 1 gigabyte per second reads. Second, as a queue system where each message gets processed once using select for update skip locked. For row locking, a 4-CPU instance processed nearly 3,000 messages per second. The replicated setup maintained over 2,000 messages per second. The larger instance reached 20,000 messages per second. And the author argues most companies operate at scale where PostgreSQL performs okay. The organizational overhead of adopting specialized systems, learning, monitoring, deployment process, operational expertise often outweighs performance gains at small scale. And the next article is about supply chain attacks. It's the following article here. Security researchers discovered that a campaign called Phantom Raven that exploited a weakness in NPM, the package manager for JavaScript and TypeScript. Attackers uploaded over 100 malicious packages to NPM that were downloaded more than 86,000 times since August. The attack exploited remote dynamic dependencies, a feature that allows packages to download code from external websites during installation. Normally, dependencies come from NPM's trusted servers and are visible to developers. But remote dynamic dependencies can fetch code from untrusted domains, even over unencrypted HTTP connections. Malicious packages showed zero dependencies to developers and security scanners, hiding the fact that they downloaded harmful code from attacker-controlled servers. And this design creates additional risks beyond hiding malicious code. Attackers can serve different payloads based on who requested them. They could send clean code to security researchers while targeting corporate networks with malicious versions. They could also serve legitimate code initially to pass security scans, then switch to malicious code later. The malicious dependencies collected sensitive data from infected machines, including environment variables, credentials for GitHub, Jenkins, and NPM, and information about continuous integration systems. And this stolen data could enable more supply chain attacks. Many malicious packages used dependency names that AI chatbots hallucinate when developers ask for coding help. Developers trust these AI suggestions and install packages with those names, unknowingly downloading malware. And the last article, this is about blockchain, and it's the following article here. Romania banned Polymarket, a prediction market platform, for operating as an unlicensed gambling service. The National Office for Gambling blacklisted the platform after trading volume exceeded $600 million during Romania's presidential and local elections. Polymarket gained attention during the 2024 US presidential election when it showed different odds than traditional polls for the Trump versus Harris race. You may remember that I also discussed these predictions, and this platform allows users to bet on political outcomes using cryptocurrency. Romanian regulators stated that Polymarket operates counterpart betting, where users bet money against each other on future outcomes. This qualifies as gambling under Romanian law, regardless of using blockchain or cryptocurrency. The platform lacked required licenses and failed to implement fiscal reporting, player protection mechanisms, and anti-money laundering oversight. Polymarket calls itself an event trading platform, but regulators argue its structure meets all legal definitions of gambling. Users bet money on uncertain outcomes while the platform takes a commission. Romanian internet providers must now block access to the site, probably via DNS. This follows similar regulatory actions in multiple countries. The United States Commodity Futures Trading Commission fined also Polymarket in 2022 for operating an unregistered derivatives market, forcing it to block for American users. Belgium, France, Poland, Singapore, and Thailand also restricted access. But despite these restrictions, Polymarket recently secured a $2 billion investment from the Intercontinental Exchange, which owns the New York Stock Exchange. And the platform plans to resume limited trading in the United States within weeks, focusing initially on the sports market. This follows a recent no-action letter from the CFTC clearing the way for relaunch. That's it for this week. See you next week.